Enjoy this movie, then visit brainpop.com for much more. Are you sure this thing is rated for this depth? You bought it from an Air Mall catalog. Oh, great. Dear Tim and Moby, when I look at a map, it seems like some continents fit together perfectly. Are my eyes playing tricks on me? From Georgia. You're not seeing things, Georgia. Some continents look exactly like puzzle pieces that snap together. Early mapmakers suspected that they were once all connected. In the early 20th century, a scientist named Alfred Wegener called this supercontinent Pangea. He thought different chunks of it broke off and slowly moved apart. Over millions of years, they formed the continents we know today. Wegener couldn't explain why Pangea split up or how. But there was some evidence to support his idea. Fossils from similar plants and animals had been found oceans apart. The age and type of rock layers matched up too. Wegener's theory of continental drift provided an explanation, but his ideas weren't taken seriously until long after he died. In the 1950s, scientists began mapping the Mid-Atlantic Ridge. It's a mountain range running 10,000 miles along the ocean floor. Tests revealed that the farther you got from the ridge, the older the seafloor was. So a geologist named Harry Hess proposed a revolutionary idea. New seafloor was forming at the ridge and spreading outward to make room for more. In other words, the surface of the planet was moving. Hess called this process seafloor spreading. It seemed to indicate that rock was being forced up from inside the planet. Nowadays, we can see this rock formation in action. Wegener had guessed something like this, but he had no way to prove it at the time. As he suspected, there's a lot going on beneath the Earth's surface. Up here, everything seems pretty cool and stable. But miles below our feet, it's a raging inferno. The deeper you go, the hotter it gets. Earth's center, or core, is as scorching as the surface of the sun. All that energy wants to escape, like steam inside a boiling kettle. It pushes outward, putting immense pressure on the middle section, the mantle. Standing in its way is the lithosphere, a rigid layer of solid rock. Well, the lithosphere isn't like a smooth shell. It's cracked into pieces, each one a different shape, size, and thickness. We call those pieces plates. Yep, the Mid-Atlantic Ridge is the border between several plates. They're being dragged apart by forces from deep inside the planet. You can think of it like a pot of soup. The Earth's core is the burner, and the mantle is the boiling soup. As the soup near the burner heats up, it becomes less dense and rises. When it gets to the top, it cools off and sinks down toward the heat. In physics, those are called convection currents. A similar process is driving the mantle, and it's taking the plates along for the ride. That movement is called plate tectonics. It's the engine driving the constant transformation of our planet's surface. Plates have been bouncing off each other for eons. The oceans have expanded and contracted. Land masses have smashed into each other and broken apart. The plates move about as fast as your fingernails grow, so we don't see the ground sliding around under our feet, but we do sometimes feel it. Yep, I'm talking about earthquakes. Seismic activity is greatest along plate borders. At convergent boundaries where two plates collide, at divergent boundaries where they pull apart, and at transform boundaries where they slide past each other. At all three boundaries, there's enormous pressure on the Earth's crust. That's the topmost layer of the lithosphere. The pressure can build up for years. The longer it takes to release, the bigger the earthquake. Yep, and plate movement drives volcanic activity too. At divergent boundaries like the Mid-Atlantic Ridge, there's a gap in the lithosphere. So magma, molten rock from the mantle, is constantly pushing up along the boundaries. These are the most volcanically active places on Earth. Volcanoes are also common at boundaries called subduction zones. That's when a dense ocean plate converges with a lighter continental plate. The heavier plate gets pushed below, down into the mantle. Some of it melts, and the magma erupts farther inland. The Ring of Fire is a massive chain of these volcanoes. Dense sedimentary rock making up the Pacific seafloor is subducted, transformed into metamorphic rock through pressure and heat, and then recycled as igneous rock through volcanic eruptions. In other words, plate tectonics drives the rock cycle, the constant process of transformation and renewal of the Earth's crust. It also creates our most prominent geologic features, mountain ranges. That happens when two continental plates converge. Since they're both about the same density, neither one subducts. Instead, it's like a slow-motion car crash. The plates buckle and warp. The land pushes up into jagged peaks. The Himalayas are still growing from a plate collision that began 500 million years ago. Yeah, Alfred Wegener's theory has come a long way in 100 years. He was practically laughed out of the scientific community for his ideas. But today, plate tectonics is the unifying theory that ties together the entire field of geology. What do you mean, out of juice? We're stuck here? Ah! Now what? Oh, thank you. Visit us at brainpop.com for more on this topic and hundreds of others. You'll find movies, games, quizzes, and activities. Learn more about the difference BrainPop can make.